All right, in the next example here, we have researchers who are monitoring a number of wolves and rabbits, and they have put together a hypothesis that the wolf population depends on the rabbit population. So they've collected the following data, and one of the things I want to point out here is that if you look at this study, it only extends for 7 years. So they're really, it is a longitudinal study, but in terms of longitudinal studies, a 7-year study is a pretty narrow window, so just keep that in the back of your mind when we're going through this. So A part, create an appropriate scatter plot. Again, when you're doing this on a test, I'm just going to tell you to do it, and I'll be able to judge from the later information that I ask whether you did it properly. So again, you hit Stat on the calculator, Edit, and you can pause here for a second because I've already entered the data in. Okay, your next step is to go to the window, and the window, when I'm looking at my rabbits, I see that it looks like the smallest number was 39, upper number was 78. So I've gone 30 to 90. You can really pick whichever range you want. You want to make sure all the data is represented so you can see all the points though. Y min, Y max. Again, 24 was the minimum, so I picked 20, and 50 seemed to cover the upper end. So now I go to graph it, and that's what my scatter plot looks like. So what I'm going to do is I'm going to take a bit of a screenshot here because I want to point out a couple of things. And it's just easier if I do it that way. Oh, perfect. So when I'm looking at this this particular graph, I have a couple of concerns because when I go to do a line of best fit, and this is just in my head, and this is what you want to be thinking about. For me, that looks like a pretty good one if I ignore this point. So the question is this an outlier? And what's the result going to be? So there's my scatter plot. There's A part. And like I said, you're not going to be able to copy that into your notes as easily as I am. But it's more of a checklist for you. Yeah, it's done. B part then. Determine the degree of correlation. Again, what I will do is I will give you a computer screen or a setting so that you can just fill the information that appears on your screen, and I can determine whether you entered the information properly at that point. So to do that, I go back to Stat, over to Calculate. We're still in linear regression, so hit Enter. And yes, I want you to do that. And there is our analysis. And again, I'm going to write it down or copy it onto the page here for myself. And you can write down the information for yourself. So now I have a bunch of information that I can use to answer the rest of the question. So B part. Determine the degree of correlation. That's my R value. And this one turns out to be 0.82. Very, very similar to the other one. So R equals 0.82. So that's a fairly strong correlation. So a strong, positive, linear correlation. Okay, not perfect. It's still almost 20 points off perfect, but it is fairly strong. C part. This is the new part for this unit here. Determine the linear equation. I've already gone through this in the previous lesson and talked about it in the previous example. So again, A is the slope, and it tells you your A value. So my equation, y equals 0.53x plus my B value, 0.77. And here's the important part. You need to identify variables for me. So y is the wolf population, and x is the rabbit population. All right. So there's ABC, and then on to D. Does the data support the researcher's theory? Well, when I'm looking at this, I'm asking myself, well, does it support their theory? So on D part here, I would say yes. The correlation is strong. However, and this is where that critical thinking part comes in. It's not perfect. Oops, I just want to put, it's not perfect. So there is an outlier, and in the next example I'll talk about analyzing or looking at the outlier and how it influences it. It's not perfect, so this may be because, and this is the critical thinking on what other factors may play a role. So this may be because what would cause either population to fluctuate? Because we know that it's very, very difficult to find a natural habitat. So we may have drought. Okay, if there's not enough vegetation, rabbit population would reflect that. Developments. As we spread out and our towns and cities spread out, it affects the environment around us. What else would be a factor? So we have drought, we have developments. It could be change in migration. Change in migration. So maybe the wolves are on the move. Okay, so there's other factors, and this study, with the data given, this study is fairly limited. It's only a 7-year study, so it's not what I would call a very, very thorough longitudinal study. And when you're looking at other factors that could play a role here, it's very tough to make a conclusion based on this. And that's why it's important when you do your project, you get as much supporting evidence as you can and ask the good questions. So, next example. Effect of outliers. Outliers can greatly affect your resulting data, and it's important to critically analyze your scatter plot. So that's very similar to what I was looking at before. I saw an outlier. I saw my R value in this example wasn't too bad. It is strong. Taking out the outlier would only make it that much stronger. So the question is, how much stronger would it have made it? So when we go through here, we want to look at in this example what effect the outlier will have. So I'm going to enter this data into the calculator, and we'll go from there. All right, I'm back, and I entered the data into the calculator, so I'm ready to analyze it. I'm going to go to my window. My X values are the hours spent. So I see it goes down to 6. I'm going to go down to 0. It seems kind of reasonable here. I see the upper one's 21, so let's go 25 hours of the excruciating torture you went through in the driver's training. When I look at the scores, I see the scores range from 15 to 82. So again, I think 0 is reasonable there, and probably a score of 100 is perfect. So 0 to 100 seems to be a reasonable selection. So when I go to it, you see quite a spread now here. And the question becomes, A, do you think there is a relationship? And B, what data are you disregarding in order to get that relationship to fit? So I'm just going to take a quick snapshot of that for us so I can point and click and stuff. So first things first, when I'm looking at that graph, that scatter plot, I have some major concerns here. I see up here, this is not too bad. However, these two guys seem to be outliers. So, A part, what assumption is the instructor making? So let's get that taken care of first. So if the instructor is comparing training hours to test scores, the assumption is that the more hours spent, the better the test result. All right, so that's the assumption. So let's analyze that data. Let's take a look at it and see what we think. So we're kind of doing B and C at the same time here. So I'll put B and C. Analyzing the data. Let's put it in the calculator and see what comes out of it. So let's do the statistical analysis at this point, and we'll find out what that result is. Sorry about that, I think I cut out. So did the linear regression analysis with the calculator, and what I found was our suspicions were correct. Our R factor is 0.277, so very, very weak. Very weak relationship. Now, if we want to take into account our outliers here, so those are the two that I identified up here. What I did was I went back into my data and I found those two and I deleted them. So when I bring up the calculator here, I've gone through the list, I've deleted those two items, And I'm going to redo the analysis. So if I go back to my scatter plot, I've gotten rid of those two outliers. If I want to do the analysis one more time just to see what the difference is, do my linear regression, all of a sudden my R value jumps from 0.28 up to a 0.92. So removing those outliers made a significant change in that correlation. So here's the challenge for you when we go through this process, especially with your project. Because now the question is, A, should I have removed those outliers? Was it valuable? So now we have a very strong. All right. So was it a valid conclusion to make? So that's when you reflect back on, and that's I think what question D is getting at. Determine the effect of the outliers. Okay. D part, the outliers play a significant role. I mean, when your R value goes from 0.28 all the way up to 0.92, okay, that's a huge, huge jump in correlation. So here's the question then you need to ask yourself. Is the relationship here, first of all, is this relationship something that should be tested, the hours versus scores? Now, as students, you'll each have an opinion on this, but I think most of us can empathize with the fact that some people can study for a particular task, and those hours don't represent, the grade doesn't represent their outcome. For myself, when I look back when I used to study for or work on English essays, I would put a significant amount of time into my English essays, even though it didn't show. So, you know, if I put in 10 or 15, 20 hours, my result was a 75. Okay, that's really good for me. I was jumping in the streets, whereas there's some individuals in this class that could put 5 hours into it and probably walk out with an 85 or better. And that's just because you have natural talent. So when the instructor has to be very, very careful with this, because what happens is these outliers or these students, so to speak, there's a lot of factors that factor into this on whether you can actually remove them. Okay, if you have someone, for example, the 20 and 45, okay, if they own no car, if they don't own a car, or parents, and never been in one, okay, never been in a car, never actually had to ride around in one, now wants to get their license, it's like starting from ground zero. So got to be very, very careful when you're comparing data and exactly figuring out what conclusions you want to draw from that. All right, so just keep that in mind. So yes, if you think you have one or two outliers and you can justify removing them, then definitely it improves our correlation. But you need to be careful, because the question is the two pieces of information that you're comparing, is it a valid comparison? So please keep that in mind. So there's the textbook homework. Good luck. If you have any problems, you know where to find me.